In this video, I'll be showing you the process that I use to assemble this little RP2040 development board that features an RP2040, which is a QFN chip with 400 micron pad pitch and a USB-C connector that has a 500 micron pad pitch. And I'll be using a reflow solder process where I'm going to apply the solder paste with a DIY laser cut stencil made from 4mm thick Mylar and a 1.6 millimeter thick chipboard frame that I'm going to use to support the Mylar stencil as I lift it off of the board to get a print of the solder paste. And we'll be using a reflow hot plate to actually reflow the board so that we can get a good view of the components as they reflow. So I have here a blank board that I've taped down to my mat using this double sticky Scotch removable tape, which does a really nice job at holding the board down, but it's also very easy to remove the tape. So this will hold the board down when I lift the stencil off and hopefully allow me to get a good print. So I've got the stencil here aligned with the board, and I'm holding the frame down both with magnets. I've got a magnetic whiteboard underneath the mat and also some blue painter's tape here on the side. And so what I'm going to do is I'm going to apply some thermally stable SAC 305 lead-free solder from Chip Quick. First thing we have to do is really stir the solder paste up to make sure it's nice and spreadable. You want to work it and mix it up using a craft stick for that. It wasn't too long ago that I stirred this up, so it's in pretty good shape, but it's always a good idea to give it a good stir. Then what I like to do is I like to apply the solder paste to the edge of a plastic spreader. I'm using a 4-inch plastic spreader here, like you might use to apply a plastic body filler when you're doing auto body work. I like to cover the solder paste up so it doesn't evaporate. And then what I do is I apply the solder paste in sort of two passes. I hold this at an acute angle as I apply some even pressure to spread the solder paste over all the apertures. And then I go back over at an obtuse angle to collect the excess solder paste on my spreader. And now I'm going to scrape the excess solder paste from the spreader back into my little jar. To try to not waste the solder paste. Just cover it up. Clean those off later. Now what I like to do is I like to hold the edge of the stencil frame with my left hand as I lift up in one clean motion with my right hand. And now we'll just peel off the blue painter's tape and see how we did. That looks like we got a very nice print. See if I can get in here a little closer with the microscope. See if I can focus it. So there are no pads that don't have solder paste on them. and they all look nice and distinct without any smearing. And so I'm going to call that a good print. Okay, so now I'm going to clean up the stencil and clean up the spreader, and then I'll be back when I'm set up to place the components on the board. Okay, now it's time to place parts. We have here a part sheet, the vacuum pickup tool, and we have the interactive bill of materials that will show us where the various components are going to go. So I like to have my components facing horizontally, and so I'm going to peel back the tape. The first components are some 0402s, first couple actually, and so I'm going to use this little pink needle to place those. Well, the rest of them are in the other orientation, so I'm going to rotate the board. Okay, first component placed. Next component is also in a 402. Back to the other orientation. So second component placed. Next component is in 0603, so I'm going to use the purple needle. These are lure lock needles, so it's very easy to change them. And the next component is up here. Now we're back to the 0402s. Pin back the tape. The other orientation again. Okay, that one is placed. Now we're in the other orientation again. Okay, now we're into some LEDs. These are 0805s, so I'm going to use the light green needle. In this case, I want the board oriented this way. next LED. Also an 0805. Okay, now we're doing the flash memory, which is a WSAN 8. So I'm going to use this large green needle. In this case, I want the board oriented this way. Looks pretty good. Okay, now we get to do the QFN. And to do the QFN, it looks like I'm going to need to have the board oriented this way. And again, I'm going to use this large green needle to pick up the QFN. I'm basically lining it up as best I can with the corners of the silk screen, which indicate the corners of the body of the IC. And it should align itself as long as we're within basically a half a pad. And that looks pretty good. Okay, now we've got a little SC75, which is in this case an OR gate, discrete OR gate. I use the purple needle for that. And we are in a good orientation for that with the board as it is. Now it's the voltage regulator, which is a SOT23. And I'm going to have the board in this orientation for that. I guess I typically use the light green needle for SOT23s. And now we have a little NeoPixel WS2812B. And this orientation for that. Is basically a little bit bigger than an 0805, so this needle is appropriate. Okay, now we're doing the crystal oscillator. Actually, it's a ceramic resonator. And I think the purple needle is going to be the appropriate one for that one. And the board should probably go in this orientation. And we've got two tactile switches. And for that, we'll probably use the light green needle, about 0805 or so in size. In this case, I'm going to want to rotate the part sheet. And now it's the USB connector. And so those tapes don't typically adhere very well to the part sheet. So I've got that in a separately. We can try using the chunky or the large gauge needle, dark green needle for that. Not sure if that'll work, but we can try. Yeah, not so much. Guess we can try the section cup. So here I've got a green needle with this kind of a smallish section cup. And that picks it up, no problem. That looks good. parts are placed. I'm going to fire up the reflow hot plate, and I'll be right back. In this segment, we're going to be doing the reflow soldering of our RP2040 development board. We're going to be using this reflow hot plate. I'm going to initially adjust the temperature setting to 155 Celsius. And once it reaches 155, I'll be starting this 1 minute and 30-second timer for a preheat phase to allow the solder paste to activate. And once that timer is done, we will move the temperature up to 235 Celsius. And once the temperature gets up to about 217, which is the melting point of the SAC 305 solder alloy that we're using, we'll then start a second timer for a minute and hopefully get a nice reflow. Now we'll let this cool down, and then we'll take a look at it, inspect it, and then solder the board locks on the USB-C connector, assuming there's no bridges. If there are, we'll clear them, and we'll be back in a minute. Okay, in this segment, we'll take a look at the soldering, the reflow soldering job, the results of that. So here we have the RP2040, and it's looking pretty good. There are no bridges on all four sides, which is fantastic. And looking at the USB-C connector, it looks like there's no bridges there either. I don't see any components that have tombstoned. Generally looks pretty good. All right, so our final task in the assembly is to fill these holes here with the little board lock tabs with solder. I'll be using a SAC 305 wire solder from Kester with no clean flux, 15 mils in diameter. I'm using an 800 degree Fahrenheit soldering iron tip. There's two. And there's the other two. You can see a little bit of flux residue there. Clean that off with a little isopropanol. And then we should be all set to test it out. Okay. In this segment, we're going to be firing up our board and seeing if it works. We're going to try to program it using the Arduino IDE to get it to flash the onboard user LED using a blink sketch. So first thing to do is to plug it in, and if it doesn't have any program stored in program memory, what should happen is that the green power LED should go on, which it did, and it should show up as a drive RP2. So the Raspberry Pi RP2040 has built-in firmware that allows it to show up as a USB thumb drive, and you basically upload code to it by dragging the file with the executable code in a proper format onto that drive and then resetting it, and then it boots up the code that you programmed in. So that looks promising. So we're going to start up the Arduino IDE. And I have here my blink sketch. So to set up the Arduino IDE, to be able to program Raspberry Pi Pico boards or boards that have the RP2040, you basically have to put a particular URL here in this part of the preferences menu. It says additional boards manager URLs, and this is the Arduino Pico project, and so you basically just cut and paste that URL from that GitHub repository into this location here, and then you click on OK, and it will load that in. I've already got that installed. And so if you go here to board, we're going to select from the Raspberry Pi RP20 boards. We're going to select generic RP2040, and we're going to do flash size 16 megabytes, no file size, because we have an 128 megabit flash on this board. So it's got 16 megabytes of flash memory for programs, and it looks like you can have it set up so that you have 8 megabytes of program storage and an 8 megabyte flash file system, which might be a nice option in some cases, but in this case we're just going to use the 16 megabyte no file system option. And we are going to compile this code. So this should blink the user LED at 1 Hertz. The blink interval here that I have is 500 milliseconds. So that should turn the thing on for half a second, then off. And let's see if that works. So and there we have it. Flashing at 1 Hertz. Okay, so suppose we want to change it. We can change this from 500 to, I don't know, 1000. And in order to put this back in bootloader mode, we basically have to hold down the boot switch while we reset. And now the LED is no longer flashing, and we have the RPi RP2 disk showing back up again. And so we should be in a position where we can push this back out. And now it's flashing at half a hertz with a period of 2 seconds, 1 second on, 1 second off. And so that's it. The board looks like it's working fine. And thanks for watching.